talk a little bit more about circles. We're going to review a little bit of vocabulary, and just going to talk about how some things work with circles. Here's a circle, a tangent line. A tangent line is a line that just barely touches the circle. It touches at exactly one point. No more, no less. Secant. A secant is a line that crosses at 2 points. So here's the secant, here's the tangent. Now, every secant creates what is called a chord. A chord is just that segment that goes inside the circle. It goes from one edge to the other. Now, there's some special relationships that are created, especially with a tangent line. It's very, very important. Tangent line. If we have a circle and we have a tangent line, okay, and if we draw a radius to that point of tangency, there's something really cool that happens there. What does it look like is happening? You're absolutely right. It is always going to be perpendicular. So that is a very important note. It's always going to be perpendicular. Now, what if we have a radius coming out, and it's actually perpendicular to some chord? So what if I know that these are perpendicular? There's something really cool that happens here as well. All right, now, we know that radii are exactly the same length all the way around, right? So I can draw a radius in anywhere my heart desires. Anywhere, doesn't matter. These are always going to be the same length. Now, if I already know these are perpendicular, these are the same length, we share that side, what do you think's got to be true about the other side? Yep. It's going to split that chord right in half. So whenever you have a radius that's perpendicular to a chord, it is also going to bisect the chord. Now, this next part I want to review a little bit of Algebra 1. Because since we're talking about perpendicular a lot, we want to find the equation of a line that's perpendicular to y equals 2x, but goes through the point 6, 10. Now, if we are perpendicular to this line, well, that line's slope was 2, so our slope, perpendicular, is negative reciprocal. Negative reciprocal means I'm going to take the reciprocal of 2 over 1, it's going to be 1 over 2, and take the opposite sign, so it's going to be negative 1/2. Point slope is the easiest way to write the equation of a line. I don't care what you think. It is. The 6 is going to be our x1, 10 is y1. This is our slope. Y minus 10 equals negative 1/2 x minus 6, and I am so done. This tells me everything I need. It tells me a point that's on the line. It tells me the slope. I can graph from that. Now let's talk about how this could be useful by looking at a couple of examples here. I'm not going to do them all. Find the equation of the circle with center 4, negative 3. Okay. That is tangent to the y-axis. Okay, so here's my y-axis. It's tangent to the y-axis. Well, that's a horrible circle. Okay, we know the center, and we're tangent to the y-axis. Well, that means 1, 2, 3, 4. That means my radius is 4. My center is 4, negative 3. Oh my gosh. I can write the equation for that. Okay? What about, let's see, those are easy. Alright, what about this one, number 6 here? Find the equation of the circle passing through points 5, 3, and 5, 9. Five, 3, 5, 9 up here, and there's a radius of 5. Okay, so we know we're passing through those points. Now, it doesn't necessarily say that that is the center or not. Is that the diameter? I don't know. Could be this way, could be this way. There's several different ways that this could be drawn. Now I know the radius is 5. So let's think about this. Radius is 5 units. So if I draw on the radius, that's 5 units away, 5 units away. Now one thing that's going to be really nice here, this chord, remember this is perpendicular, right? If this chord is straight vertical, then the radius to the center here is going to be horizontal. That's 5, 3, 5, 9. So my center, or at least the y coordinate of my center, has to be halfway between 3 and 9. So it's going to have to be 6. So my center is going to be something 6. Let's see if we can do anything else. Let's take this point up here, 5, 9. And this is my center. I don't know what that first one is. That's an H. I know the second one is a 6. And I know the radius is 5. Could I do a little bit of Pythagorean theorem? Sure. The x values. I have H here and 5 here. So that's H minus 5 squared. Y values, 9 and 6. That's 9 minus 6 squared equals the radius squared, 5 squared. H minus 5 squared plus 9 minus 6 is 4. Gosh, it's 3. 3 squared is 9 equals 25. H minus 5 squared equals, it's going to give me 16. The square root is going to be plus or minus 4. So I have H minus 5 equals positive 4, or H minus 5 equals negative 4. That's the option. I will get H equals 9. Over here, H equals 1. Now, do you agree that that center could have been over here at 9? Or could I have drawn the circle this way and still been good? Yeah. So you actually end up with 2 equations. We have one, which is going to be x minus 9 squared plus y minus 6 squared equals r squared, which is 25. The other option is that our x, the center, is at 1, 6. So we end up actually with 2 different circles. So that's just a little bit about how you can use some of these properties of circles